right, good morning, good morning, good morning. Get started here in about a minute. All right, here we go. Any questions on the homework? Hold on one second. I had somebody just send me something. Okay. Questions on the homework? Okay, here we go. It was classroom exercises 1 through 7 all and written exercises 1 through 16. So let's see, classroom exercises 1 through 7. The most specific name, it would be a trapezoid. Now it's also quadrilateral. Number 2, it is a quadrilateral, a rectangle, and a parallelogram. Number 3, it is just a quadrilateral. I'm trying to do 4 things at once here. I apologize. Number 4, it is a quadrilateral and a parallelogram.
Microphone.
Sorry? Okay. Number 5, it is a quadrilateral, a trapezoid, and a isosceles trapezoid. Remember, isosceles trapezoid is when the 2 legs of the trapezoid are congruent, and that's what it appears on number 5. Number 6 appears to be a square. A square is a rhombus is a parallelogram.
Too much of.
That's a rectangle is also a parallelogram, and the whole thing is a quadrilateral. All right. And then the last one, number 7, that is a quadrilateral, parallelogram, and rhombus. That takes care of the class exercises, written exercises 1 through 16 all. Number 1, the angle measurement will be 115 degrees. Usually I have questions on this one. The reason why is simply because let's see, you have 2 parallel lines cut by transversal, so corresponding angles are congruent for that one. Number 2, PQR is 65 degrees. Why? Because of answer number 1. Who's ever audio is on, please turn it off. Please turn your audio off. Thank you. All right, number 3. Opposite angles of parallelogram are congruent, so number 3, angle R is 115 degrees. Number 4, angle S would be opposite angle Q or PQR, therefore it would be 65 degrees. Side RS, which is opposite side PQ or QP, that would make it 12, and QR is opposite PS, that would make it 7. All right, number 7, name 3 congruent segments. So remember, for a parallelogram, opposite sides are congruent, and it says it's an isosceles trapezoid, so that means its legs are congruent. So the 3 congruent sides would be AB, EC, and DC. Number 8, give a reason why angle CED is congruent to angle A. It's because corresponding angles are congruent to parallel lines cut by transversal. Number 9, name 2 other angles congruent to angle A. There's a couple options here. Angle BCE, angle D, it says 2. There's a third one, angle CED. Name an angle that's congruent to angle B. That would be angle AEC. If you said angle E, I know what you meant, but remember angle E would refer to 2 different angles. You got to be more specific. Number 11 is true. Number 12 is false. Number 13 is true. Number 14 is true. Number 15 is true. And the last one, number 16, is false. False, false, false. All right, that was it for homework corrections. We're going to do a last section today, chapter review tomorrow. Tomorrow will be a quick class. I'll just basically say, hey, here is the chapter practice test. Maybe make some quick notes about it, and then I'll say that's it for the class. If you want to hang around tomorrow to have some questions answered about the material in the chapter, I'd be happy to stay on the entire time. If not, then I'll close it. And then obviously on Wednesday, there will be no class. I will post the test by 7 o'clock. You can take it whenever you want. Don't take any longer than 50 minutes to take the test, but you don't have to take it at 7 o'clock. You can take it at any point, but some people like to get started on things, so I'll allow you guys to make the decision of when you want to take that test. We'll jump into chapter 7 material at the end of the week, and then we'll take Thanksgiving break. Hopefully we meet in person that following Monday, and we'll drive on from there. We will not get past chapter 7 in the book before Christmas, so we'll finish up with chapter 7, then we'll take semester finals, and then we'll take Christmas break. I love this time of year. All right, here's your homework for tonight. Once again, notice we have both class exercises and written exercises. We have both for the last section, 6.8. A lot of notes to take today. If things go too fast for you, remember I will post the meeting. Excuse me. I will post the meeting sometime between now and 4 p.m. So you can always play the class while you're doing the homework. Okay. Remember the all this stuff right here is also posted on the homework assignment. I had a bunch of people this morning saying, where's the link for the class? The link never changes. It's always this link for class. Also, every single assignment, except for maybe the chapter test and quiz, every single assignment that I post on Teams has a link to this Zoom meeting. So you can just pull up an old one and find that link. It never changes. All right, last section is entitled Polygons and their perimeters. All right, so all we're doing today are perimeters of polygons. We've done perimeters of circles. We call that a circumference. C is equal to pi times the diameter. Now we're going to do the perimeters of polygons. 3 objectives today, 3 objectives. All right, we've already written this down. Polygon, a closed, meaning you can't get to the inside without crossing a segment. Closed plane, meaning it's on a flat surface. Closed plane figure, fancy word for shape. Closed plane figure consisting of segments that have been joined at their endpoints. New definition in red here. Write this down, please. A side. We're specifically talking about a side of a polygon. These are the segments, plural, that make up a polygon. Remember, the smallest number of sides we ever have is 3 for a triangle. Sides are those segments. Now, we've seen some sides in our quadrilaterals. We've seen on a trapezoid we have bases and we have legs. We've seen on a right triangle we have legs and hypotenuse as well too. But all of them can be generically called sides. The other thing of note on a polygon are the corners or the angles formed between any 2 consecutive sides. We are going to call those the vertices. Vertex singular, vertices for plural. These are the points, and it's literally a point where the segments join each other on the polygon. Those are called the vertices. So 2 new definitions, although we've been using them. Sides and vertices. Sides and vertices. We've already written down polygon a couple times. Sides, the segments that make up a polygon, and vertices, point where those two segments come together. We okay? All right, moving on. So let's make something. Well, there's a side because it's a segment. There's another side. It's but notice where they come together, we're going to call that a vertex. I'm going to put a whole bunch of segments together. I have made a polygon. This one has 5 sides. So remember, the blue part right there is not part of the polygon. That's the inside. But we do have the sides from the sides of the segment. So we got 1, 2, 3, 4, 5. And then also notice that since 2 sides make a vertex, that we would also, since all 5 sides come together, that we would also get 5 vertices. So if it has 5 sides, it has 5 vertices. If it has 6 sides, it has 6 vertices. Okay, that is your basic construction of a polygon. All right, I said today was going to be definition intensive or a lot of vocabulary. So now what we're going to do is write down the names of our polygons. So this might be the slide that some people are slow at writing it down. All right, the goal here is not for you to actually draw the polygon. Your goal here is to identify the polygon by the number of sides. Now remember, since sides also equals vertices, some people tend to identify them by vertices. Either one is true. So we've already had our first 2. The first one is called a triangle. If it has 3 sides or 3 vertices, it's called a triangle. That one's the easy one. And the second one we've also had, if it has 4 sides or 4 vertices, it's called a quadrilateral. So the rest, what I'm going to show you, are what you're responsible for. And yes, on the test, I literally may just show you one of these and ask you what is the name. Now, I do want to remind you is that for triangle and quadrilateral, we have lots of names for the type of triangle: isosceles, scalene, equilateral, or by angle measurements, acute, obtuse, or right. For quadrilaterals, we have bunches of those: parallelograms, rectangles, square, rhombus, and trapezoid. We have lots of those. For the following, from sides 5 on upwards, we're not going to go over the types of those. We're just going to talk about the generic one, the one that has 5 sides. The one that has 5 sides is called a pentagon. Penta meaning 5, gon meaning angle or corner. Pentagon. These are going to come fast and furious at you. If you have 6 sides, you are a snowflake, and all snowflakes have the shape of this. It's called a hexagon. If you ever look at, if you want to Google after this class, Google snowflakes, and you will notice they all form or the shape of a hexagon. They all look different, but they all have 6 sides. Hexagon has 6 sides. Hex meaning 6, gon meaning angle. 7 side, the one that no one can remember its name of. Jaden, do you remember? I'm assuming Jaden's here. He's not here. What do you know? Is called a heptagon. A heptagon. A heptagon. H-E-P-T. It means 7. Heptagon has 7 sides. It's kind of weird looking. It's kind of a combination of the hexagon and the pentagon, how you draw it. Eight side is a stop sign. All stop signs have 8 sides. It is called an octagon. Octa meaning 8, gon meaning sides or corners. Octagon, 8 sides. Now, I made all my shapes with PowerPoint, and PowerPoint does not have a 9-sided polygon drawn for you. However, 9 side is called a nonagon. Nonagon. You want to draw one that's kind of a combination of a heptagon and an octagon. And the last one that you're responsible for has 10 sides. And at 10 sides, if we can do 10 years, it's called a decade. So a 10-sided polygon is called a decagon. Decagon. And for some reason, PowerPoint has a 10-sided, but not a 9-sided. No love for the 9 sides. What you're responsible for, you need to know all your triangles by angles and by side measurements. You need to know all your quadrilaterals by angles or by shape. But for the rest, from pentagon all the way up to decagon, you simply need to know that a pentagon has 5 sides and 5 angles. A decagon has 10 sides, 10 angles, and all the ones in between. So I will use these words. You just need to know how many sides. So not too bad. Most of you have them all memorized, probably except heptagon and nonagon. All right, we good? Okay, moving on. So these are called special polygons, and they're somewhat special, but they just differ from the normal ones. So we're going to have 2 of these. The first one is called a regular polygon. A regular polygon, and this one always confused me in 8th grade. I didn't figure this out until sophomore year of high school. A regular polygon is a polygon made up of congruent sides and angles. That means if you're a regular polygon, all the sides have the same measurement. So for instance, if one side is 5 centimeters, all the sides are 5 centimeters. And what confused me in 8th grade is this angle thing. So it says all the sides and all the angles are congruent. For some reason, I thought that the angles and the sides had the same measurements, meaning like if the side was 5, the angle is 5. That's not what it says. It just simply says that the sides are congruent and the angles are congruent. So for instance, on an equilateral triangle, all the sides are, for instance, 5 centimeters, and all the angles are 60 degrees. So notice they did not match. That's what makes a regular polygon. All the angles are the same, and all the sides are the same. But we are not saying that the angle measurements equal the side. Maybe I'm only saying that because I made a mistake on that. No one else does, but I say it all every year. So those are called regular polygons. We like regular polygons. They look nice and pretty. So for instance, a square, all the sides are the same and all the angles are 90. A square is a regular polygon. Okay, so all the sides have the same measurements and all the angles are 90 degrees. Those are the 2 requirements if you are a regular polygon. We okay? Okay. So let's see if we can visually identify which ones are regular. So 2 requirements, all the sides have to be equal. So clearly this one, it looks like a rectangle, is not a regular polygon. But the square, the one to the left of it, is a regular polygon because all the sides appear to be the same and all the angles are 90. Well, on this right triangle, clearly all the angles are not the same because if you have one that's 90, the other 2 would have to be acute, and visually it certainly appears that the sides are not the same. But an equilateral triangle is regular. All the sides are the same, all the angles are 60. For a hexagon, now clearly this hexagon's been stretched, so all the sides are not the same. But if it's regular, that means all the sides are the same and all the angles are the same. Okay? When we take high school geometry, we will have a formula that calculates the angle measurements of all regular polygons, but we don't have that this year. Okay, so that's the first thing they're going to have you do is just identify regular. So regular, regular, regular. The other ones, well, if you're not regular, then you must be irregular. Okay, irregular. All right, so quickly, this is just a quick identification thing. Tonight for homework, they're going to have you do something with regular polygons. So I'm going to skip this slide. This was just identify the ones that were regular and move on to the next one. All right, so the next game, write this down, please. This is the main goal of today, is perimeter. And perimeter we will define as the distance around a shape's edges. In other words, around a shape's sides. So the edges of a polygon, that's the same as the sides. If we measure all the way around that shape, we have calculated its perimeter. We've calculated its perimeter. So the process to calculate a perimeter of a polygon is you simply find all its sides, find all its measurements, and you add them up. So that's all you simply do is you add up the sides of the polygon. Now it sounds pretty simple, and it is simple, except they're going to make it more complicated because now we know we have some special shapes out there. We have regular polygons, we have types of triangles, we have types of quadrilaterals. So to make it more challenging, they're simply going to take some of those special shapes and ask you to calculate the perimeter In other words, some of the side links will be missing, but since you know something about the shape, you will be able to conclude what their side measurements are because you know the shape. So for instance, if it's a isosceles trapezoid, you know that both legs of a trapezoid are congruent to each other. So maybe they only label one of them. All right. To calculate the perimeter of a regular polygon, since the definition of a regular polygon is a polygon that has congruent sides, you simply take the measurement of one of the sides and multiply it by how many sides it has. So I'll say that again. If you're a regular polygon, so it's important if you have this word right here, regular. So if it's a regular polygon, you simply take the measurements of one side and multiply it by the number of sides that you have. And you will have that tonight for homework. We'll do a couple of examples as well. So perimeter is not a very challenging thing in knowing what to do, but it certainly requires a little bit of math. And especially if you're calculating a decagon with 10 sides, you can easily make a mistake if you just simply do a math error. So be careful. So we'll do an easy one first. Here's clearly a triangle. It's got 3 sides. It's not regular. Notice all 3 sides are different. But if we're calculating the perimeter, we simply add up all the sides. And yes, I will insult your intelligence by doing this. So that's a 4 plus a 7 plus an 8. Remember, addition is commutative. You can add them up in any order you want. So maybe there's a way of adding them up that makes your life easier. I like adding up even ones first. 8 plus 4 is 12. Plus 7 is 19. Therefore, we get 19 centimeters. Make sure you put the units. If there are no units listed, then you will put the word units. Units. So here's what I mean by they're going to use some previous information. Notice we have a triangle, and it appears to be an isosceles triangle, and they only list 2 sides. They will require you to understand that since it's isosceles, that the side with the 1 tick mark is congruent to the other side with the 1 tick mark. Therefore, if this side is 7, then the other side must be 7 as well too. Therefore, this one, 7 plus 7 is 14, plus 8 is 22. We get 22 centimeters. Stop me if you're lost on what I'm doing. No? Good. All right. Ooh, notice we have a regular triangle right here. So it's a regular polygon, all 3 sides of the same measurement. How do I know that? Because of the tick marks. They only give us 1. So the rule is you take what you're given for one side, I'm given 5, and you multiply it by how many sides. Remember, this is only for regular ones. So 5 times 3 is 15, or 3 times 5 is 15. So you get 15 centimeters. Okay? Okay. All right, so on your own, I'll give you about a minute to do these calculations. Calculate the perimeter of all 3 shapes. So we got a triangle, a trapezoid, and a quadrilateral. Calculate the perimeter of all 3 shapes. All right, Jace, what is the answer to the first one, the triangle? What is the perimeter?
7.
Jace says it's 7. He knows it's an isosceles. 2 plus 2 is 4 plus 3 is 7. It's in inches, Jace, so make sure you put inches. All right, Lucia, what do you got for the trapezoid?
I haven't gotten it yet.
All right, tell me what to do.
You add each side
All right,
together.
8 plus 5?
13,
Plus 7.
20,
Plus another 10.
30.
All right, so you got that one. And Amber, you want the last one? What do you got?
I haven't finished that one yet.
All right, tell me what to do.
40 plus 40.
That would be 80.
And then I would do 42 plus 42 and then
That
add
would be
those.
84.
So 80 plus 80.
164. All right, so 164, and that's in centimeters. Everybody got this? Pretty easy, right? Okay. Moving on. So that's one of three. We're going pretty quickly. Now we're going to do the opposite. If there's a challenging part, this is the challenging part. They're going to give you a shape and tell you its perimeter, and they want you to calculate one of the sides. Sounds like an impossible task. So what they do is they will always give you a regular shape. Notice it says I have a regular pentagon. What's special about a regular shape? It means that all the sides have exactly the same measurements. So if all the sides have exactly the same measurements and they tell us, notice they tell us that the perimeter is 20, well, we can set up a quick equation, right? That one side would be, I don't know, S, right? Please stop. If all the sides are the same, we simply, and I put S for sides. Notice S looks like 5, so maybe an X. We would have that the P for perimeter is equal to 20 centimeters. And to find out the perimeter of a regular one, you take one side, S, and you multiply it by how many sides you have, which is 5. So if the perimeter is 20, then we simply do this. And so for whoever who just guessed 100, you were completely and totally wrong, right? Because the perimeter was 20, not a side was 20, the perimeter was 20. So to solve this one, we divide both sides by 5. 20 divided by 5 is 4. So it turns out that the side length is 4 centimeters. 4 centimeters. Okay? All right, so that's how those are going to be done tonight for homework. They're going to give you a regular something. Simply take the given perimeter and divide it by how many sides you have, and that's how you get to your answer. All right, one more. So it says a regular, in this case, a regular octagon. So you have to look at your notes and say, well, how many sides does an octagon have? Octagon has 8. So this would be, the perimeter is 96, so this would be 96 divided by 8. Because remember, perimeter is found by taking the side length of 1, that would be S, and multiplying it by how many sides you have, 8 for an octagon. So I take 96, divide both sides by 8. 96 divided by 8 is 12. So we get 12 inches. Questions? Nothing? Okay, cool. Moving on. So we've done for regular shapes. We also need to do irregular shapes as well too. So the last one we'll do is we'll look at when the shapes are irregular. Remember, we've done this before with complex shapes. These are shapes made up by 2 or more other shapes. So here's an example. Well, let's see. This looks like it's made up of, if I draw a line right there, a square and a triangle. Now here's the kicker, right? They're going to ask you to find the perimeter of this shape. And remember, the perimeter goes all the way around the shape. So even though this shape is made up of a triangle, right, and a square, right, we will not be using this part of both the triangle and the square to calculate our perimeter. So we're going to calculate the side length of this red here, of this one, plus this one, plus this one, plus this one, plus this one. So it's important that you think this completely through before you actually do the math of what you need to calculate. So the perimeter of complex shapes, right? If I'm given all the measurements, which you won't, right? They will measure. Oh, by the way, this doesn't look like a square now. It looks like a rectangle, but that's okay. You simply add up the numbers that you need. So which numbers do I need? Well, let's see. I need this one. I need this one. I need this one, and this one. I do not need the 8 right here because that's not part of the perimeter, that's on the inside. So this would be 10 plus 10 plus 8 plus 10 plus 4. All right, so this one will require some scratch work. Try not to do the whole thing in your head. But if you were to do this math right here, and let me clear out the rest of this mess, you would simply add those numbers together. So 10 plus 10 is 20, plus 8 is 28, plus 10 is 38, and 38 and 4 is 42. So 42 centimeters for this one. Also remember this, right? I can take away some bits of information if I tell you what the shape is. If I tell you the bottom shape is a rectangle, then I don't need to put the measurement right here or the measurement right here, because we know that opposite sides of a rectangle are congruent. Therefore, I know that this side is 8. I'll leave off the units here. I know that this side is equal to 10. So we can use that to assist us. And by the way, it cleans up the picture a little bit as well too. So be ready for that for homework, where they only give you some information. Okay. All right, so we got a T here. Clearly a T is made up of a bunch of rectangles. So the question is, well, how do we handle this one? So step number one is usually to break the shape up into recognizable shapes. So if we break the shape up into recognizable shapes, well, the top part is a rectangle. So we know if this side is 2, then the other side is 2. Here's where your issue is. If you immediately write, well, I need this side and the opposite one is 10, well, that's not it. Because remember, 10 would go all the way from here all the way across. So if I stop right here, notice I'm stopping right here. If I stop right here, if this is 4, then this piece is 4. And if I stop right here, then I know if this side is 4, then this side is 4. 4 plus 4 is 8. That leaves a total of 2 left over for that piece right there. You see how I got that? And if this side is 5, and this side is 5. And now we have everything that we need in order, I'll make it nice and pretty now. We have everything that we need in order to do this calculation. We found out that side was 2. We found out that side was 5. Is everybody tracking on this one? All right, that's a lot of numbers to add. So absolutely positively be careful. What I would do is off to the side scratch work. I would write 2, and then I would draw a line through it. So I'm starting with 10. So 10 plus 2 plus 4 plus 5 plus 2 plus 5 plus 4 plus 2, and that way you won't skip a number. Okay. If you're trying to do the whole thing in your head, well, okay, these numbers are pretty simple, but just be careful you try to do the whole thing in your head. 10 plus 2 is 12, plus 4 is 16, plus 5 is 21, plus 2 is 23, plus 5 is 28, plus 4 is 32, plus 2 is 34. I'm getting 34, but I easily could have made a mistake there. You don't have to do this in your head, okay? Questions? All right. I told you today would be a quick class. That's about it. I'll hang on, until the next class. If you want to chat or send me a quick answer. Hey, by the way, your teachers have already identified who in your class is messing around on Zoom. We know who you are. It tells us who is messing around. It tells us every time someone draws, someone kicks someone off, it tells us who did that. Please don't do that. Don't get yourself in trouble. Most of you kids are fine. You don't even know this stuff. But for those of you that were messing around, we know who you are, and the emails are going out today. All right. So do a good job on this. If you need any help on your homework, let me know. And if not, any questions? We'll do a review tomorrow, remember, and then on Wednesday won't be a class. There will just be a test. You got 50 minutes to take the test. We'll talk about it tomorrow as well too. So no questions. I'll stop it right now. You guys have a wonderful day, and I will see you guys tomorrow.